Good afternoon. This week I am summarizing Chapter 17, The Importance of the Transition Years, Grades 7 through 10 in School Mathematics. This article argues that in grades 7 through 10, that's some of the most critical years in a student's mathematical development because they have to completely change how they're thinking about mathematics. During these transition years, this article talks about how students are moved from seeing math as arithmetic or memorized steps, and they have to move beyond conceptual and procedural memorization that they are used to, and see math as an idea, a system of ideas. It calls out that in just 4 years, these students are expected to make several shifts mathematically, and they talk about 7 important transitions. The first one, from whole number to real number, from number to variable, from properties of individual figures to general properties of classes of figures, from inductive arguments to deductive ones, from operations on 2 numbers to statistics with sets of numbers, from informal description to formal definition of mathematical ideas, and from a view of mathematics as a set of memorized facts to seeing mathematics as interrelated ideas accessible through a variety of means. He goes on to say that most of these transitions are not met, and then specifically talks about how in middle school we tend to either remediate or accelerate, and remediation looks like slow students with elementary school mathematics, and then acceleration with faster students with high school mathematics. He said also that in middle school mathematics, it's not necessarily mathematical, but pedagogical, and teachers use group work, projects, and explorations, but they do not give attention to the transitions that he named above. From the transitions he named, I do think that we don't do a good job of going deep into having students shift their thinking about mathematical ideas to systems of ideas. The article goes on to talk more in depth about each transition and what that looks like mathematically, provides examples. Pretty interesting because having taught middle school, we don't go this deep with the concepts. So this was an interesting read, and something to think about in terms of preparing students truly mathematically for these concepts. In the end, some of the solutions that he presented in order to shift this, of course, is to ensure that curriculum and instruction and teacher preparation intentionally focus on helping students make these deep connections and transitions. Talked a lot about how this needs to happen in teacher preparation programs so that teachers have a better and a deeper understanding of these concepts, and then they have to teach to this level versus teaching to the watered down side or just the surface and basic memorized facts and memorized procedures from what we're used to.